Okay, so here we have a right triangle, and they want to know what's the value of x here. So we can use special properties of triangles. If we have 30 and 90, this is a 60 over here. And there's a wonderful relationship, of course, because in a 30, 60, 90, this leg right here, right? This leg right here is half the hypotenuse. It's 12. And then you can quickly find x using the Pythagorean theorem. Um, but but I'm going to use trig here because I'm trying to get practice with trig ratios and getting those across. So let's use that. SOHCAHTOA is my go-to acronym for trigonometry. When I say SOHCAHTOA, I write it like this because S is for sine, C is for cosine, T is for tangent, and the letters next to the S and the C and the T represent the ratios of the trig functions. So here, if we're starting with 30, right, and we want to find x, I would actually say, okay, well, I'm going to use my tangent function because the tangent, right, of 30 is equal to the ratio of the opposite over the adjacent, right? I'm sorry, no, we don't have the opposite. I'm not going to use tangent. I'm going to use the cosine because the cosine of 30 equals a over h, or the adjacent, this side right here, over the hypotenuse 24 over here. So it's x over 24. This is fairly easy to solve because to find what x is, if x divided by 24 is the cosine of 30, that means if we take 24 and multiply by both sides, that 24 times, and I'll abbreviate, the cosine of 30 would equal x. And we can just plug that into our calculator. The cosine of 30, right, is this decimal right here, times 24 is 20.784609. And, sorry, here we want to round to the nearest whole number, so 20.78 is really 21, or choice 3. So it's an irrational side length, and that makes sense because here that will always happen with these triangles, 30, 60, 90s, I believe, like, I can't think of any example, but I think you'll always have at least one irrational side, right? And there's a proof, now that I'm thinking about that, involving the radicals connected to this irrational relationship. All right, thanks.